Good evening. It is day 21 of this series. Um, I said again that I'd be recording this in the morning, and it's not the morning anymore. So another relatively short video today, um, where I'm probably just gonna do another two leak codes, and then I want to. I mean, we can just plan this out right now. I ended up skipping, so plan for deep work number 20. Um, I did two leak codes, and that was actually about it. And then so plan for deep work number 21 is going to be another 1 to 2 leak codes and finish planning visualizer app. That way, okay, so is um the idea is okay, obviously I'm going to go over 1 or 2 leak codes tonight and do those on trees, and then I want to finalize the idea of how I'm going to build out this code visualization, or I guess STEM is what I was saying, visualization, but for now it's just code visualization. My God, bro, I fucking um okay, but let me restart here. I want to plan out the actual technology that I'm going to be using and the just the overall how I want to approach this. What does the UI look like, right? Maybe get like a little Figma done. Um, what are the actual features of this? Um, like I said, what tools are we using? Are we using a framework? Are we just going to use raw JS? Do I want to try HTMX? Do I want to um, for like a back end, what do I want to use? Do I want to use Oh my God, do I want to use SQLite? Do I want to use MongoDB again? Do I want to do AWS? There's so many things that I need to think about for this. And so hopefully I can do that tonight. I do, however, need to go do something in a second. So after I'm done this intro, I need to go for like an hour, and then I'll be back, and then we can do that. And hopefully I'll go to bed at a good time tonight, and then I'll be up early, and we can have a pretty solid day of working on this project. So yeah, um, that's about it. I'm trying to think if there's anything I'm leaving out here. I don't think so. I think that's all I wanted to talk. Oh, I don't know if you saw, they came out with a new O3 model for OpenAI, which I looked over like briefly. It looks like it's very expensive, like to actually like compute. They had this graph that they showed, which just seemed fucking so misleading. It was like showing for a problem, right? How well it did on the problem. And so the graph went like percent accuracy on the problem and then cost per that task. And it was an exponential on the X. It went like $0, $5, $10, $100, $1,000, and then it ended there, right? And so the next one would probably be 10,000, right? And so but then on the thing, it was like, oh, I plot, these right here, like all the other models, and then O3's up here. The model that scored like 40% cost $7 to do that. The O3 that got like 87% cost like almost 2 grand. Like, I don't know how they're gonna make that like it's because it's not publicly available right now. So I don't know how they're gonna make that publicly available without going bankrupt. So we'll see how that goes. But yeah, um, I will be back in like an hour to do these leak codes and then plan out the product for this weekend. So be back in a second. I'm back, and I have Christmas lights. Um, Yeah. I don't know. Anyways, so LeetCode or NeetCode, whatever you want to call it. We're on mediums for trees. Yes, sir. Okay. Given a binary search tree where all nodes, where all node values are unique, and two nodes from the tree P and Q return the lowest common ancestor. Between two nodes P and Q is the lowest node of the tree T such that P and Q are root P and Q. The lowest common ancestor between is a tree T. Okay, so this is 5. And if we're given 3 and 4, 4. I mean 3. Oh, okay. I kind of get it, right? So like if we have 1 and 9, 5 is its thing. If we have 2, a 4 and 2, 3 is. So it's like you have to take the two numbers and you have to like take the shortest path up, right? And you have to find where the first node they meet at. It's like in this situation, if it was 3 and 2, right? You'd have to find a way of like, so it's like again probably a recursive thing, right? Where we take the left and right of this and we're searching, right? So in this situation, I mean immediately we would say, but what would that condition be? Like once I find one of these, the P or Q, what should I do? I don't know. In a situation where I find Q, P or Q, I now have to find where those two. So in this scenario, right? I find 3. I mean, I guess there's like the edge case, right? Where it's like if, but even that's weird because if I say like the current dot value, if current dot value is equal to P or Q, right? Like I guess I just keep recursively calling, and if I find, so I could have two flags. I could have a Q found and a P found, right? No, because after it's not a true false type of thing. It's a This is weird. Let's think about this. Um, no, TLDR. Oh, it's fucking snowing in here. Okay. Look at how festive this is. This is snowing and I got my lights on. Crazy. Okay. So I want. Oh, no, no, I want. Wait, I can copy image. Can I paste it in here? Oh, I can. Oh, can I? Oh, yeah. Yeah, yeah, yeah. Nice. Okay. So if we had something, I need to change this color like blue. So if we had something, right, and we go to 5 first, I get underlined in, maybe better, right? We go to 5. This is the current node. And so what are we trying to check? We're trying to check at each node if it's equal to P or Q, right? So nope, this is not equal to P or Q. Do a recursive call on both sides. Is this equal to P or Q? Is this equal to P or Q? Yes and yes, right? And so it's like, okay. So now what do I do in this situation, right? We want to treat these as like exclusive, right? Do I want to say like a path to that? Like from, like maybe I'm saying, okay, this is its parent node, right? So from this node we save it and then we go down. Is it equal to that? Nope. So we add 5 to its list. And then we go down. Oh, this could be something. So then we go down. So this is add to 5. So I go here, and both of these have 5 in it in its list. So we would say it's 5. Now, in the event that it was 8 and 4, right? This has 5 and then it has 3, right? So we know the only thing to get to 8 is a 5, right? So then we get here and we're like, okay, are there two values maybe that match? Oh, it says unique values, right? All all node values are unique. That is very big. So that means that all we have to do is keep keep track of the nodes that we're visiting, right? Right. So visited 5, and then we get to 8. So we only have 5. Visited 3, visited 5, visited 3, got to 4, right? So look at both lists. What is the common overlap here? It's 5. Return that. Okay, we can do that, I'm pretty sure. Yeah, I'm pretty sure we can just do that. So what that looks like is we're not making any I mean, I guess we literally could just call this first, right? Def find um uh find LCA, right? Pass in the node. Um and so what's gonna happen here? So we have the root of the tree, and we want to say, okay, I would assume if first off, if node dot value, well, first, if node is none, not node, if node is none, what we return none. And then also though, if the node dot value is equal to p or node dot val is equal to q, then um we want to return just the node value, right? Because that'll be that. Otherwise, we want to say, okay, cur equals node dot val, left equals node dot left, and right equals node dot right. And so we want to say, okay, if left is not none, right? Then we want to recursively call find the LCA on left, and then if right is not none, find common ancestor right. But I guess this is weird, right? Because we say, so I kind of don't want this, right? Oh, you know what it should be? It could just be because if we visit five, right, and five is equal to that, we still want to add that to the list because it doesn't hurt adding the current value to the list. So this can just be actually, um, so before we go through, we want to say, actually, no. We want to say this, but instead of returning something, we want to say, well, no. We want to keep track. We want to keep track of we want a P list and we want a Q list. I guess it's more like a path, but whatever, it doesn't really matter. So we have our P list and we have our Q list. We want to say, okay, I guess that is true. How do you like, how do I know which one is leading to P and which one's leading to Y? I mean, I guess I could call in the recursive call if it's left or right, maybe, right? So like if we're going down this side, we put, I mean, I guess so, right? You would add five, you'd add three, and then if you went here, you'd add four, you'd add one, you'd add two. Oh yeah, this is weird though because it's like if it's all on the same side, because it can be on the same side, right? It's not like it's on both sides of the tree. Oh, this also does kind of flaw this approach, right? Because it's saying like if it's on the same side and it goes five, three for this, three and five will overlap. So that won't work actually. Back to the drawing board. Okay. Okay. Oh, did not want to delete that. Just move this up really quick. And let's just delete all of this. Move you back down. Okay. So how do we do this? Well, I guess that could still work in a way, right? Like, okay, let's say we just start going down, correct? I use pink. We start going down from five. I like red, but I'm just. So we start at five, right? And if this is P, right? If P, I guess whichever one I find first. So, okay, let's say we go down here, right? And we say, is this P or Q? No, it's not. So now we go down here, we say, is this P or Q? No, it's not. Is this P or Q? And let's say this is. And it's like, yep. Well, what path of recursion did we take? We took 5 to 3, 3 to 1, right? And so we could say, okay, this path, 5, 3, 1, is P's path, right? And now let's say that let's say 4 was our, so let's say this was P and this is Q, right? And so we would run into this first, right? And so it would maybe terminate. Anyways, let's say it didn't terminate and it went through anyways, right? Our same list would be 5 to 3, and there'd be 3 to 4, right? So now we have a 5, 3, 4. What we can do is, because yes, there are two things, we just look at the closest value that matches. So we just go back between, we start at the end of the array and we just go forward and we say, do these values match? Do these values match? Right? And even if they're like the different um side, oh, I guess we wouldn't do diagonally. We'd start at like the longest one, right? Maybe like whichever one's longest, and we go and we just like check, okay, does this value match anything? Does this value match anything? And we'd start from the end, right? So for example, in here, or we could always just start with the same. Even if this was 4, right? 4 values, and we start with this one, we could be like, okay, 4. Does 4 match with 1? Oh, it doesn't, right? Go back. Does 3 match with 3? Yes, it does. 3 is what we want, right? So still think this path thing can work. It's just a little different approach. So I can still keep this list in list, but instead what we're doing is we're saying, okay, actually on every single turn, we should just be saying, we should have the P list, we should have the, I should rename these the path. These are definitely just like path. Path and cur path, right? This is just the current path that we're going down right now, right? And we just say, no matter what, every time we call this, or no, it should be in here. It should be, if left is not none, like before I call this, I want to say the current path dot append cur, right? This is the current value that we're on. And then we go. Now, if if the current value that's being passed through is equal to the value of P, right? And this would be P dot val, I'm pretty sure. Is equal to the P dot val, because this is a tree node. If these are equal to each other, then we want to say that P dot path equals the current path. Let me make sure, pen the last one, go to the next one, and if that equals that, then we're not including current path. Okay, that's fine. That's the current path. And then we can say return. Just get out of here. We don't want to return any values. We now have our path. So return. This is the only thing, though. Do you think, I don't think this is valid, but can I say, like, while P path and Q path are none, then we do a recursive call of find LCA on root? And then once these have values in it, then we can say, okay, then we want to do like we can do like, okay, P path for value in P path if starting, how do you start from the end of array? How do you loop through a Python array backwards? For I in reversed. Okay. If the value equals reversed I guess this is for value and then for value in reversed Q path. I need to rename this to for Q, whoa. In Q path, if the P value equals Q value, return P value. Else, if it never equals this, I guess, no, at the end I can say return none, right? And then what am I missing here? I mean, I have the if no dot val equals Q dot val, then Q path equals the current path, and then return. And then this would also be current path dot append. But this is weird, right? Like, this is just weird. Yeah, and that doesn't make any sense. I knew this was just gonna be kind of wrong. So let's think about this. So I'm calling this recursive function on the root. I'm saying, okay, if this value is equal to this, then if this is equal to the P value, then that's going to be the P path, if not. So I think that logic's pretty good. It's this recursive knowledge, though, right? Okay, if our left value is not none, then we append to the current path. So we'd append right now, we'd append 3. And if right's not run, we'd do this. So now we have 3 and 8 in the same array, which isn't what I want. Actually, you know what I could do is I could have a current, this is something I could do, is do a current left path and a current right path, right? But now I'd have to say, instead of just if no dot value is equal to the P value, right? I'd have to know a way that either the left or the right path is equal, right? It'd have to be a way for me to know. Because the idea here, right, is that like I'm saying, okay, left path, append this. Then I go here and here. Oh no, because then this would be okay. Never mind. Never mind. Scratch this. Scratch this. Okay. Let's start from scratch here. What do I want to do? No matter what, I want to just get the path Honestly, I'm gonna chat GPT this. I've already spent a decent amount of time, and I think I would get the okay for this leet code problem. I don't know what to do with this. Ab okay. P path and Q path. Define path. So there's a node, there's a target, and there's a path. If if not node, return false. False. Okay. Add the current node to the path. Okay. Check if we found the target value. Explore left and right. If no, the left. Oh yeah, I hate this syntax. I hate this syntax. Path.pop if the target is not found in either subtree. Okay, yeah, so this removes the things I don't want. Find paths to P and Q. So it does root PQ, P path, Q path. Okay. Ancestor equals none. For I in range, min length Q path. Okay. Let me see if this works first. The fuck? Oh. That's maybe why. Okay. So it works. Let me see if I can understand this a little bit better. Move this again. Wipe you away. Ba, 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 ba. Okay. Bring you back in. Red. Okay. So, move this Grammarly shit out the way. So, what's happening here is we are saying, okay, we're passing through, we're doing two find paths, one to find P and one to find Q, right? And then we pass through our path, our P path or our Q path. So, at first, we have the root node, our desired target, in an empty path. We path append node, right? Path append node. If this value equals our target value, we return true. Otherwise, we now go left and right. So if node.left and a recursive thing, or so this is the syntax I don't really understand. But basically, all it's saying is if the target is not found when we do this, right? We want to do um, we just pop off the entire path and return false. Interesting. So we do that for both. So I guess I am a little confused on. One second. I need to look at the DM. All right, I'm back. Okay. Node left checks if the current node has a left child. Oh, it just checks that and then it does a recursive call. Okay. That's all I needed to know. I don't care about that. Target is found. True. If the target is not found in either subtree, the function removes the current node from the path. I see. This is what I thought, but start at root 5, path equals 5, left child exists 3, so check that path. Move to node 3. Path equals 5, 3. Left child exists 1, so check path. Neither child exists, so we remove 1 from the path. We're back to node 3. Check the right child 4, call this. Node matches, so we return true, and the path equals this. Ooh, okay, yeah. I mean, that was literally what was in my head on the logic side of this. The only things that changed is this was smart to do two separate calls on this and just have one checking for that. I should have known to do that. And I think my other thing would have worked. So it's just different syntax. So yeah, I mean, logically this one was pretty easy on what to do, on just finding both the paths and looking for an overlapping value. The soonest overlap, the soonest, not the most recent, sorry, is what I was trying to say. Overlapping value. Okay. Okay. Binary tree level order traversal. Okay, given a binary tree root, return the level order traversal of it as a nested list or each. Oh, I see. Well, right off the bat, I can say if root is none, return. Maybe not none, and then if root. Um. Oh, okay. Return. Kind of return that. Oh, I guess there's no whatever. Right. So if it's absolutely nothing. Oh yeah. Wait, no, this one was right. It was I wanted to do a return that. Okay. There we go. Yeah, those are those edge cases dealt with. Um, okay. So now we can get into some logic here. So it should be form tree, right? Obviously, I want node. I think I want a level, right? Also, I can just put this in here. That'll probably be easier. Um, Also, this needs to go forward one. So the idea here is going to be Oh wait, no. This will be outside. I don't want to check this every fucking time. Duh. So, okay. So the idea here is, I don't know if I'm gonna need level, but we'll see. I mean, ideally, it's literally just. I mean, I could say if level equals 1, right? Then return tree dot append 1, right? And then I want to say, okay, current equals node dot val. Always want this, right? I like doing left first. Left equals node dot left, and right equals node dot right. So we want to say, okay, if, again, if the left is not none, then form tree passing through left. If right is not none, form tree passing through right. Level plus equals 1. Level plus equals 1. Again, I don't know if I need level right now, but it's whatever. So the whole idea here, right, is not only do I want to recursively call it, is outside of level 1. I mean, I can't I mean, technically I could hard code every level, and I could just say on level 2, blah, blah, blah. But it should just be, form tree left is called first. It should go through, and it should just take its current node and append it, right? Or actually, can I not just do node.val appended? I mean, I guess it does have to be in its own. It does kind of have to be in its own array, though, right? Right. So if I just did this and I did it run, I never wait. I never called this. So I mean, just for like right now, if I did form tree on root and then I return tree, right? Right now it's doing the 1, 2. Oh, that's pretty messed up though. Oh, you know what I could do? I could just make a dictionary. Um, level dict, and I could do passing through a level. Each level plus equals 1. Level plus equals 1. Um, and I still do this, except instead of doing return tree.append, I'll do level dict. Has it dot add? Adding values to dictionary in Python. No way it's dot update. Oh wait, what am I saying? What am I saying? What am I saying? I know how to do that. It's I do if level dict at node dot val. No. At level. Oh no. I just say level dot dictionary at level. If if it exists, then I want to do how do I like oh, it is just dot append. Okay. All right. Get out of here. Comments. So level dict at level dot append node dot value. Otherwise, we want to set this equal to that node dot value. Okay. Oh, does this do no level return? Okay. Very good. Very good. I know it looked a little off. There's only one problem with that though. If I print off level dict, right, and I run this. Level plus equal 1 is invalid syntax. Huh. Oh. Sorry. One is a one, two is two, three is three, four, five. Okay, perfect. I actually didn't think I was gonna append that well. Beautiful. And so I just have to turn this into a an array of arrays. So that should be what? That should be what? For index in range of the length of the level dictionary. I want level dictionary at index. And this should also be 1 to the length. To the length plus one level. Um, level dict at index. I guess it's just return tree dot append. No way. Bro, Python is so funny. Python's so funny. I can just loop through and then do an array dot append the dictionary array at that key. Oh my God, that felt good. I will not lie to you. Doing this, no ChatGPT help. I mean, other than for some reason I was blanking on how you append stuff to that. But I mean, other than that, wow, that felt good. I did that like really fast as well, right? I think I did that in like 15 minutes, like a medium tree question. That feels good, bro. I'm finally getting like a better understanding of how this is working. I won't lie. There's one thing I really want to work on coming up, and it's like I understand recursion of trees to an extent, but there's still a little bit of fuzz there. There's still a little bit of fuzz that I just want to completely clear up. So I'll take sometime this week to just before I move on from this, uh, clean that up. But yeah, I mean, this was very solid what I just did. I'm really happy with this solution. I'm sure there are depth first search, node depth if not node, if the length of result is equal to depth, zero. Zero. Res dot append. What? Is literally what I did though. If the length of this is equal to the depth, append nothing? That's kind of weird, nah? And then res at zero dot append the node value and then recall this. So this only hits on the first one, nah? Oh. I see what it's doing. It's saying every single time you get to a new depth, just add a new array. Just add a new empty array. And it's saying, okay, now res at depth dot append this. So it's just saying the subarray in here, which is this, just append the value and then recall this, increasing the depth. So it's the exact same thing that I did, just a lot more cleaned up. Because what I was doing, wait, so do I not need this? Oh, okay. Oh, okay. I guess it is because if there's nothing, if it's empty, right? Then return tree is this, and so I'm just returning that. If it's one, this isn't nothing, and so I'm saying I'm appending this, and I'm going through, and this is none and none, so it's going to, it's just going to exit out of this, and it's going. All I have is one in a subarray, which well the dictionary, and the dictionary turns to an array that gets appended to the original thing. So that covers both of those cases. Um, But yeah, the thing here is that he's directly making the array that needs to be made. I'm doing a dictionary, right? So They both work, but his just, a little more efficient. So, time complexity here would be this is O of n. I think recursion's also O of n. In dictionary search and time complexity of a dictionary append. O of 1. Wow. So I would assume this code is just O of n time, right? What is the time complexity of this problem? I'd assume O of n. I don't see anything that goes above O of n here. Form tree O1 because we're just checking a key. Appending overall is O of n. Yeah. Okay. Beautiful. Okay, that's what I wanted to do for that. Still have a little work on the visualizer app, but I'll do this later. So, visualizer app. Visualizer app. Projects, code visualizer. Open. Yo, can you thank you. So, technologies to be used. Okay. So, oh shit. So for actually like the structure of the website, right? So I was thinking, I was like, okay, I want to use a lot of new tools here because I have the time to do so. But like what could I actually use? And I think either if I'm feeling adventurous, I could use HTMX, which I'm pretty sure HTMX um HTMX allows WebSockets, blah 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 blah, simplicity, blah 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 blah. What is HTMX used for? Is a small dependency-free JavaScript library creating a cousin user interface with ease of hypertext markup. HTMX is a library that allows you to access modern browser features directly from HTML rather than using JavaScript. Okay, so it's a JavaScript list thing. Okay, yeah. So I think either we use JavaScript or we use HTMX. Um, I want to see, is HTMX good Reddit? It should already be used when combined with a backend framework for templates like Flask or Django. You're building a website, you're working in HTML, but you want to alter DOM response for user input. It's not possible with vanilla HTML. Enter React. You can think in HTML through JSX, but you have no way to respond to user input. However, interesting. Okay. You know what? You know what's never going to go away and what is amazing to build fundamentals on? Good old JavaScript. So I think I'm just going to do JavaScript. I think I'm going to do the whole entire application running off of JavaScript. I mean, obviously, I need like a root for HTML, so I'll just do JavaScript and HTML. Now, um, obviously that's going to come with stuff, but I'm looking at just the big ideas here. So, what's next? Well, I need a database. I need backend, and I need. I guess that's fine, right? So, I kind of wanted to try AWS, because I haven't, and I know it's pretty popular. I've done MongoDB, I've done SQLite, which I really liked SQLite. Um, so I'll actually say this. I'll actually say AWS or SQL. But it would be nice to be able to put AWS under some right, type of. The thing is it's like I don't want to uh have like a bunch of stuff I'm trying to learn. And then it's just like it's so much. Like I should stick to like core things. So it's like maybe I do stick with SQL Lite and don't try AWS. But I don't know. There was also something I wanted to look at, which I'll just put in double question marks, which is microservices. Now, obviously, for something that I'm building, I don't think this has any actual benefits, right? I'm pretty sure microservices are for big scale applications, and microservices, from what I have read of them, is like mini virtual machines that get booted up pretty quickly for individual parts of a website, right? So actually, I'm going to take it away because I don't think this is the time nor place for that because it's just going to be like a one page thing. But like, I'm pretty sure that is just what microservices are, is like kind of modularizing more than stuff is already modularized. Whoa, slurring words here. Um, and the fact of like I can boot up a small VM for a user, and multiple users can use multiple like smaller virtual machines. I think it's been a while since I looked at them, so I could be just absolutely way off the mark here. But it's like opposed to just having everyone and like all time running a server at all times to do all requests from everyone. It's like, okay, what if we started up servers and have them like micro servers everywhere, and we had them running for like 10 minutes, and so that way these things will like, if at one point 10,000 people are using our service, right? And then it goes down to 2,000, instead of having the ability to host 10,000 people, it will slowly go down. And then there's like probably like a buffer there, right? For every person, new user that like is interacting, maybe two machines are spun up, right? Or when you're anticipating higher traffic, you automatically have virtual machines that spin up, and then those are used to deploy, more connections or whatever the fuck. So I'm pretty sure that's what virtual machines are. So in my case, it's just not worth the time, I don't think. Um, so for backend, um, as in like the server, right? So I mean, usually I used like render. Um, what do most people use for a server or a website? No, I mean like, Hmm. So it's a virtual machine. Obviously, that's 100% running all the time. So I mean, what AWS again, right? Just double AWS it up. I use this site called Render, um, and it just hosts my files. So anyone, I can just hook my back end up to it, like my database. Um, and it can automatically send requests, right? So it's just always up. So, what was like the other stuff? Docker, other tools. I wanted to use Docker. Um, what is Docker? I mean, I'm pretty sure it's just it like keeps everything at the same package level or something like that. Um, Docker is the platform for building and running applications in container, isolated from the rest of your system, as everything it needs self-contained. From a very high level, it looks like each application is running its own virtual machine from a technical. Wrong. Many different applications running their own Docker containers on the same machine, not conflicting with each other. The main use of Devin is for being able to deploy your application on any server without having to worry about installing other dependencies or getting conflicts with other applications. You can also use Docker to run your application locally for development the same way. Okay. Docker. So it just containerizes something so that it's not like interacting with your system. Like it's not depending. Like right now, my configuration of an application on my machine might not work on someone else's because I have certain things installed or running or whatever it may be. But like if I have it in a Docker make build, whatever you want to call it, it it only accesses what's in this container. So that way, if I send the container over to someone, ideally it should be the same way, right? Okay, so we'll look into Docker when building this. Um, so anything else? So I'm gonna build the front end using JavaScript and HTML, and any add-ons this comes with, right? Like I wanted like drawing on the screen. I'm assuming that's just gonna be an add-on, like a package. For the database, either SQL or AWS. We'll see. Back in AWS or Render, right? Um, and obviously Node. What is there anything? Is there anything else but Node to run a backend? Serverless. Oh, yeah, that is true. I'm gonna put serverless. Look at serverless because I've heard this a lot, and I want to look into it as well. And obviously serverless is not serverless. You still have to have a server. Nothing can not just run off a server. But I'm pretty sure. Oh, this is a long time ago I looked at this, but it was like serverless is just like What is serverless? How ABM serverless is that there's no persistent thing. That is your server running perpetually, taking up resources even when it's idling. And be used to. Oh, so this is microservices now. What's the difference from serverless, and microservices? By IBM. Serverless, also known as a serverless architecture for serverless computing, is an approach to software development that empowers developers to build and run application code without having to worry about managing underlying infrastructure. Serverless routine maintenance tasks like installing operating system and software updates, managing blah 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 blah. In serverless platforms, the CSP handles the servers, freeing them up to focus on code and business logic. Okay, other advantages of serverless. With serverless, billing starts when code execution starts and ends when it ends. Okay, microservices, also known as microservice architecture, is a cloud computing architectural approach where the entire application is made up of many independent, interconnected smaller parts. Microservices applications often have their own stack that includes a database and database management model. Microservices communicate using a combination of representational state transfer, event streaming, blah, 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 blah. Didn't want to click that. Microservices are closely linked to kind of okay. Well, microservices are often talked about in the context of their architecture definition. It can be easier to understand their business value by looking at them through the lens. Change your code without a okay. Both serverless and microservices share the goal in enhancing flexibility, scalability, and complex applications. Both serverless and microservices are scalable. The difference comes in the level of control and automation. In serverless environments, management of critical microservices are less cost efficient than serverless because they're billing models. Well, serverless functions are billed according to the number of events that trigger code deployment. Microservices cost to be paid upfront based on providing. Okay. So what I'm seeing is very fucking minimal differences. Like obviously there's differences here and there, but it's like they're both just not static running all the time. It's like, oh, we're only gonna start on code deployment, or oh, we're only gonna be running enough resources for different parts of the app. So whatever. So I guess microservices are back in. So let's look at this. We'll look at serverless and then other tools Docker. Okay, so we're gonna build this out in JavaScript and HTML. Backend is either gonna be SQL or AWS. Sorry, database. Backend will be AWS or serverless. I think I'm gonna um, I'll just say or maybe render. I doubt I'm gonna do render. Um, and then Docker. I want to check out Docker. So if I can get AWS, Docker, or serverless, that's pretty good. I was thinking about like at first I was like, oh, let's do Angular, and then on the back end do fucking SQL, and then on, you know, or sorry, on the back end do serverless, and then do SQL, and then do Docker and Q. If I'm doing 8 different technologies, it's gonna take way longer to complete this. Like I should have familiar aspects, especially this. Like this, I've done multiple times building out with JavaScript. So like the actual core functionality should be fine. Database should be fair. I mean, I've worked with two different database technologies, both MongoDB and SQLite, and then backend. I've already worked with render, so I should go to AWS here, or again serverless, whatever that is, and then Docker's new. So yeah. Um. Oh, bro, I just want to select both of these at once. What does this do? Oh no. Go back. Bro, why can't I select both of these? Okay, this I want locked. This and this I want unlocked. Okay, whatever. I'll put it back afterwards. Okay, actually, whatever. Um, okay, yeah. Another shortest video. I'm actually happy with how usually these nighttime videos, especially because it's 11 p.m., are really bad. They're like terrible half the time. And today was actually pretty good. I mean, um, that second LeetCode problem was phenomenal. I literally that second one was better than any of the easy ones I did. Um, and then planning for the thing is pretty nice. So tomorrow, ideally, I am up at before noon tomorrow, and I will start recording, and we will look at the app. I mean, obviously, we're gonna do the leak codes first, but then we'll look into the application and start building it out. Start JavaScripting it up. Look at Docker. I mean, I need to look at the technologies first to see like if Docker's probably something I should configure before I start coding. Um, so tomorrow will probably be mostly a Docker day, if I had to imagine. Um, so yeah, I will see you hopefully tomorrow morning. Bye.